Welcome back to my channel, dear children. Good morning. Last class we have discussed about functions and different types of functions. In this class, children, we are going to solve some problems based on functions. So I brought some examples from your standard NCERT textbook. In general, children, if you understand the theory behind solving problems, you can solve any problem given from outside. Okay, so I have specifically taken some examples from NCERT textbook of class 12. So let me solve. Before that, let me read the question. Show that the function f from r star to r star defined by f of x equal to 1 upon x is 1 1 and on 2, where r star is the set of non-zero real numbers. Is the result true if the domain r star is replaced by n with codomain being same as r star? So here when I read, children, one new thing which I see here is r star. And what is r star? They have clearly told here r star is the set of all non-zero real numbers. Okay, and here n means natural numbers. So we are going to check whether this function under this r star and r star, it is 1 1 and on 2. And the second part is they are saying is that if the domain is replaced by natural number, with codomain being same, what is going to be the type of function? So let me start. So let us write what is given to you. I am given with f is a function from r star to r star. It is defined by f of x equal to 1 upon x. We have to check the definition of injectivity. So I am going to start with that x1, x2 belongs to r star such that f of x. So this is how the definition of injectivity says, that you take two elements from r star such that f of x1 is same as f of x2, then x1 should be equal to x2. That is the definition. So if I apply here, you can see here 1 upon x1 is equal to 1 upon x2 because x becomes 1 by x. Now x1 and x2, right, they both are given to be as non-zero real numbers. They are coming from non-zero real number set. So what will happen? You can interchange. So what will happen? Your x1 will become equal to x2, cross multiplication. So this is my condition of injectivity. My function appears to be 1 1. Okay. Now I have to prove the condition of I have to prove the condition of onto or surjectivity. So this time I have to travel back. I am starting with y belong to r star, and I am starting with an element y belong to r star, and I should be able to find an x belongs to r star such that y equal to f of x. That means I should be able to find a pre-image of y, okay, under the function f and prove the condition y equal to f of x or f of x equal to y. So I am going to start with y belongs to r star. Okay, if I am going to start with y belongs to r star such that my condition is y equal to f of x. So what will happen, children, here? Y will be equal to 1 by x. So when y will be equal to 1 by x, since x is r star, I can exchange. So x will become as 1 by y. So 1 by y. Now y is a non-zero real number. 1 is also non-zero real number. So the division of them will also belongs to r star. So what happens? For every y belongs to r star, I am able to find an x of the type x equal to 1 by y, which is also in r star. So that means I have found the pre-image. Now I have to prove one more definition, that is your x, if it is of this type, then your f of x should be equal to y. Okay, so let me start with f of x. So I'm going to start with f of x. So what will happen? F of x will become f of 1 by y. Now what will happen? By definition, what is the definition of f? Every x goes to 1 upon that number, right? So here what will happen? Now 1 by y will be 1 upon 1 by y. So this is going to be up. Why? Because y is non-zero, r star. So it is going to be y. So I have proved the condition that for every y belongs to r star, there exists x equal to 1 by y belongs to r star such that f of x equal to y. So what will happen? Your function is on 2. Okay, this is the procedure of proving the injectivity and surjectivity of a function. Okay, now coming back to the second part of the question. The second part of the question says, is the result true if the domain is replaced by R star is replaced by N and the codomain is same as R star? So this time they are saying that you exchange, not exchange, you just change the domain of your function as natural number and codomain you keep it as it is as R star and check what is the type of the function. So if I start with f of x will be equal to f of x will be equal to 1 by x. So again let me start. I am going to start x1, x2 belonging to my set of natural number. So what will happen? Such that this condition is already ready made. F of x1 is equal to f of x2. So what will happen? 1 upon x1 will be same as 1 upon x2. Now x1, x2 is natural, so denominators are non-zero, so I can cross multiply. So x1 equal to x2 or x1 equal to x2. That means what did I get? I have started with two elements from elements from my domain, and I am able to prove that if these two elements are having same images, then the elements are same. So what happens? My function turns out to be 1, 1. Okay. Now if your function, now you have to check whether your function is onto or not. Okay, so for onto, you know that children, I have to take an element specifically from R star. So I have to pick an element from R star such that f of x equal to y. Okay, now children, 90% of the times your onto function you can orally check by some examples. Okay, instead of going for the general process, you always check first orally whether your function violates or your function has some element which will violate the definition of onto, and you did not have to do the procedure of finding onto like as I have done in the previous example. Okay, so let me take one element in R star. Okay, suppose children, if I am taking an element 2 is a non-zero real number, I am taking from R star. Okay, so by according to this definition, what will happen? Your 2 will be equal to f of x, but children, your f of x is defined to be as x square, right? So now what will happen? Your x square will be 2. Sorry, not x square. I'm sorry. Your f of x is 1 by x. I'm sorry. Your f of x is 1 by x. So it will be such that 2 belongs to R star such that you have y is 2 is equal to f of x. Right? Y is equal to f of x. So if your 2 is equal to be f of x, that means children, your x should be of the type half. Yes, your x should be of the type half, because if your x is of the type half, what will happen? If I put here in the definition here, f of half will be equal to 1 upon 1 by 2. So that is 2. But children, my 1 by 2 is not there in R star. Okay, my 1 by 2 is not there in R star. So my f is not onto. Did you get me, children? I have used the counter example method. What did I do? I started with an element R star, but by the definition it says that if it is onto, then it should be of the type y equal to f of x. So what happened here? Instead of y, I put here 2 equal to f of x. Okay, but f of x is nothing but, children, f of x is nothing but 1 by x, right? F of x is nothing but 1 by x. So if my 1 by x has to be 2, if my 1 by x has to be 2, children, then my x has to be half, right? If my x, this 2 can be pulled down here, so x will become half, and half is not there in R star, right? Half is not there in R star. So you can say that f is not onto. So you can see that, children, the same definition of function, but with different domain and different domain. Here only domain is changed, your answer is changing, right? So you have to be very careful while doing the problems. Now I have next problem. I have already written it in advance. Check the injectivity and surjectivity of the following. The first one is f is a function from natural to natural, f of x equal to x square. Injectivity means 1, 1. Surjectivity means onto. Now children, in the exam it can be asked for 4 marks also. That check whether the function is bijective. So in that case, what happens? If your function is not injective, then and there you can stop and write the answer. It is not bijective. But here it is not like that. Here injectivity also also they are asked to check, and they have also asked us to check the surjectivity. So let us do it. Okay. So as usual, for injectivity, I am going to take let x1, x2 belonging to natural number such that I have f of x1 is equal to f of x2. Injectivity, most of the times we do general ways. Okay, x depending upon the set, mostly we do general type of proving. So f of x1 equal to x2 means what, children? X1 square is equal to x2 square. So what will happen? X1 square minus x2 square will be equal to 0. I have brought it here. So what will happen? This is of the type a plus b, a minus b. So x1 minus x2 into x1 plus x2 will be 0. Now one thing is very important is your x1, x2 is coming from natural numbers. So what will happen? x1 plus x2, this bracket will not be 0. Because if product of two terms is 0, that means both are 0 or 1 is 0. But here this term explicitly cannot be 0 because x1 is positive and x2 is positive. So that means my first bracket is 0. First bracket is 0 means my x1 minus x2 is 0. So children, I will get x1 is equal to x2. So I have started with x1, x2 belong to natural, f of x1 equal to f of x2, and I am able to prove that x1 is equal to x2. So I will have my function f as 1, 1. Okay. Now, coming back to onto children. Now let me start with some element y belong to natural number such that y is equal to f of x. Okay, and to prove the onto condition for this function y equal to f of x. Okay, now I have told you onto, you always check for an element which violates, or is there any element which is violating the definition, then it is very simple. You can without going for the general procedure, you can do it. Okay, so if I see here children, you can see that suppose if I am going to take an element say 2. Okay, suppose if I take an element 2, so what will happen if I take an element 2 belonging to natural number such that y is equal to f of x. Okay, so this time it will become 2 equal to x square because f of x is x square. So what will happen? My value of x will be equal to plus or minus square root of 2, which is not there in natural number. Right, I am able to find a pre-image, but what happens is that pre-image happens to be outside my set of natural numbers. It is actually an irrational number. Is that clear? So what will happen? My function will not be onto. Okay, so it is injective but not surjective. Alright, now moving on to the another example. I have f from z to z, f of x equal to x cube. Same question, injectivity and surjectivity. Okay, 1, 1 and onto. So what I am going to do, again I am going to take x1, x2 belonging to z such that f of x1 should be equal to f of x2. Right, so that means by definition x is x cube, so x1 will become x1 cube, x2 will become x2 cube. Now here children, we have the domain and the codomain as integers, and on top of it you are having a function which is having odd power, right? X cube, odd power. And we know that children, in integers, if you are cubing a numbers, your cube of a number will be same only if the numbers are same. I mean, if I have a positive number cube and if I have negative number cube, there are no chances of the positive number cube and the negative number cube to be coming out to be same. If it is a square, it can come out to be same, but if it's a cube, it cannot. For example, if I have if I take x1 as 2 and if I take x2 as minus 2. Okay, so what will happen? 2 cube will be 8, but minus 2 cube will be equal to minus 8. That means different elements under cube will be giving different images, right? No two elements can give me the same images, right? If they are giving me the same images under cube function and under integers, that means the integers must be same. That means here I can write that this situation is possible in integers only when x1 equal to x2. So what will happen? My function f will become 1, 1. Is that clear? Right? Because it is a cube function and we have the set of integers. Okay, now coming to onto, let us start with some y belonging to z such that y equal to f of x. Okay, now children, this time again I will go for some counter example. Say let me take some 7. If I take a 7 belonging to integer such that 7 is equal to f of x. 7 equal to f of x means 7 is equal to x cube. So what will happen, children? Your x will be equal to cube root of 7. Right? Cube root of 7 is not a rational number. It's not an integer. It's an irrational number. So what happens? I am able to find a pre-image. But this pre-image does not come in my set of integers. So what will happen? Again, this is not going to be onto function. I hope you have understood, right? So it is one. That means it is injective, but it is not surjective. So always 99% time, no children, counter example will very well help you in deciding whether a function is onto. But injectivity, always I think it is better you go for general method. Okay. Rare cases you can get for counter examples for injectivity. Okay, it's not that you won't get, you will get also. Okay, not injective functions. Okay, now coming to the next one. Now the next one is f is a function from z to z such that f of x equal to x square. Now the last two cases we got injective functions. So this time I have taken one function x square. Okay, cube and square. It was under natural integer. This time I have taken x square under z and z. Okay. So now here children, because it is square and because if I am in the set of integers, it makes me think why not go for a counter example, because 2 minutes back I told you that children, if different elements have same images, then elements should be same. Now it's a square function and it is an integer set. So in integers you know that there are integers positive and negative squares are same. Right, not for are same for same number, not same number, same magnitude of the number. For example, what I mean is children, if I am going to take f of 2, or let me start with 2 and minus 2 from my domain. What will be f of 2? F of 2 is going to be 2 square, that is 4. Similarly, f of minus 2 is going to be minus 2 square, that is also 4. That means same images, but what happens? 2 is not equal to minus 2. Right? So I started with f of x1 equal to f of x2, but my x1 is not coming to be same as x2. So what will happen? Therefore, my function is not injective, or it is not 1, 1. Okay. Now coming back to your onto function. So the same procedure, let y belongs to, this time my codomain is z. So let y belongs to z such that y is equal to f of x. Okay. Now if I am taking y as say minus 3. Okay. I'm going to take minus 3 belonging to z. Okay. If I take minus 3 belonging to z, what will happen, children? It will be minus 3 is equal to x square, right? So x will be equal to plus or minus square root of minus 3, which is not in integer, it is a complex number, right? It is not in integer. Y belongs to z. I have taken it as minus 3 equal to x square. So it is like this. So I am getting a complex number, right? Imaginary number. So it is not there in z. So my function is not onto. So children, before solving the problem, 1 or 2 minutes you have to take time and think, how is the function, how is the image, what is the connection between positive number images, what is the connection between negative number images. Then only you proceed, then only you decide whether you have to go for counter example method or you have to go for general method. Okay, directly don't jump, you just look at the behavior of the function for positive numbers, negative numbers. Of course, if you want, you can check for 0 also. So there are chances of less mistakes. Okay. Now coming back to the next question. Next question is, I told you again that I have taken standard examples from NCERT textbook. Okay, these are all standard examples appearing in any textbook. Okay, which teaches the topic of relations and functions. Okay, so I have taken examples from your NCERT textbook. So the question is, show that the modulus function f from R to R given by f of x equal to mod of x. I hope you know how to read it, mod of x, right? Last year you have studied types of functions, right? So modulus function, it is a modulus function, and the definition is x, where the modulus of x takes value x if x is greater than 0. It takes the value 0 if x is 0. It takes the value minus x if x is less than 0. So in short, modulus function will give the final answer as always positive, right? Modulus function will always give the final answer as positive. Now we have to decide whether this function is 1 1 or it is said, they are saying that we have to prove that it is neither 1 1 nor onto. Very simple, because by the definition itself you can see, right? If you look at the definition, x when x is greater than 0 and when x is less than 0, it is minus of x, right? So again it will be positive. Anyhow, let us do it officially. So I am going to take let f is R2. It's a last morning we have seen that it's a real function when the domain and the codomain happens to be subset of real number or real number set, then it is a real valued function. So I'm going to start with let x1, x2 belong to R. Okay, I'm going to use counter example method. So suppose if x1 is 1, what is f of x1? F of x1 will be modulus of 1, which is 1, because the definition says that it will be 1 if 1 is greater than 0. If I take x1 as minus 1, children, what will happen? X2 will be minus 1. F of x2 will be modulus of minus 1, right? So that means it is saying minus of x2. But what is x2? It is nothing but by definition it is minus of x. So it is minus of minus 1. So answer is 1. So here you can see here, children, f of x1 is same as f of x2, but f of x1 is same as f of x2, but x1 is not equal to x2 because it is 1 and minus 1. So I have proved that, therefore function is not 1 1 or injective. Second part is you have to show that it is not bijective also. It is not onto also. That means surjective. Okay. So let me take some function. Let me take some element. Counter example. I will always love to take counter example for proving the onto part. Okay. That is very easy for me also, for you also. Okay. Once you get practice of it, you can see for onto counter example is the best method. Okay. So I have real number. Okay, so I will take y as say minus 5 belonging to R, such that what will happen? Y should be equal to f of x. So that means minus 5 should be equal to f of x. But just now in the definition of modulus function, we have seen that modulus function will always give the answer as positive. So what will happen? F of x equal to minus 5 is not possible. That means what? There cannot be any element which is giving answer as its image as negative. Or in other words, I can say that in modulus function, all the negative numbers will not be having pre-images. For example, minus 4, it will not have a pre-image. If it is minus 7, it will not have a pre-image. If it is minus 9, it will not have pre-image, right? But if it is 7, I can have two options. I can have minus 7 or 7. If it is 10, I can have two options, minus 10 or 10. But if it is minus 10, I cannot have an element in R under the modulus function such that this condition is satisfied. So this minus 5 will not have any pre-image here because your image is coming to be minus 5. So I have got it. Your f is not onto also, which is the highlight of the question. Okay. Now coming back. Let's come for the next one. Let A and B be two sets such that f is a function from A cross B to B cross A such that f of A comma B is B comma A is a bijective function. So you have two sets f from A. Now ideally we have seen one set going to another set, but this time you can see that it is Cartesian product of two sets going to Cartesian product of two sets with the order changed. So we have to check whether it is 1 1. Not check, they have said that you have to show it explicitly to be a bijective function. So let me start. Okay. So let me start with now since A cross B is a Cartesian product, you know that in Cartesian product all the elements are appearing in the form of an ordered pair. So I am going to take element of the type let A1 B1 and A2 B2 belongs to A cross B such that what happens, f of A1 B1 is same as f of A2 B2, right? That is f of x1 equal to f of x2. That is a normal definition. So by this case, children, what will happen? It will be B1 A1. By this mapping, B1 A1 will be same as B2 A2. So two ordered pairs are equal. If you remember, I have told you if two ordered pairs are equal, then means the elements in the respective position should be same. So B1 is equal to B2 and A1 is equal to A2. Okay. So that means the ordered pair A1 B1 is same as A2 and B2. Is that clear? So I am able to find A1. I am able to find the images to be same. That means the elements are same. So if I have f of A1 B1 and f of A2 B2 as same, that means by this definition, if I rearrange this, I get A1 B1 is same as A2 B2. Right? That means f of x1 equal to f of x2 means x1 is same as x2. Okay. Therefore, my function is 1 1. Okay. Now let me go for onto. So I am going to start with let. Now element is coming from B cross A. So it will be B comma A. Let B comma A belongs to B cross A such that B comma A is equal to f of AB. Okay, equal to f of AB. Now B comma A belongs to B cross A means what, children? B is coming from B and A is coming from capital set A. Right? Because B is coming from B and A is coming from A. So if I consider the ordered pair, I can, if you want, I can, if I want, I can make an ordered pair A comma B such that it is belonging to A cross B. Because here again, I am able to find an A coming from A, I am able to find a B coming from B. So I am able to get an ordered pair A comma B belonging to A cross B, such that its image is going to be f of AB. And it is very simple, children. When A and B is given, it is obvious that you change the position, you are going to get your element back. If I have 1 3, you can have 3 1, right? It's just a matter of rewriting the elements here and there. Okay, so you can just go through here. A belong to B cross A such that this condition is given, but that from this set the choice is such that B is from B, A is from A. So very well I can have A comma B belong to A cross B. So this is my definition. So my f is onto. So my function f is bijective. Okay, so we are through the problem. We are able to show that the function is bijective. The last one. Now let me do one more and then we'll stop for the day. Okay, I hope you are following, children. So I have a function f from A to B, f of x equal to x minus 2 upon x minus 3, and you have a condition on your set A is equal to r minus 3. That means from your real number set, your number 3 is removed. Okay, and from your real number and from your set of B, that means your codomain, your number 1 is removed. Okay, now the first A from A real number minus 3 is removed. You can understand why it is written, because here down in the denominator you have minus 3. So if I put here 3 minus 3 will be 0, then your function will not be defined. So that is the reason they have given here. Now the second one, B equal to r minus 1, this part we have to check where it comes or not. Okay. Now what is the main part of the question? The main part of the question is you have to find whether your function is 1 1 or 1 1. You have to check whether it is f is 1 1 and onto. Okay. So no problem. But first, as I said, children, as I checked orally, I am going to check the well-definiteness of the function, which is very true. This will always exist. This always exists, right? This element always exists because my x is not 3, because my set A is defined in such a way that it is not a real number. I mean, it is not taking value 3. Okay, so I am going to take let x1, x2 belong to A such that f of x1 is equal to f of x2. Okay, now I have to land with x1 equal to x2. So I am going to just substitute the value. So x1 minus x2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. Okay, now just cross multiply. Cross multiplication is possible because denominator is not 0. So x1 minus x1 minus 2 into x2 minus 3 is equal to x2 minus 2 and x1 minus 3. Now open it. So x1, x2 minus 3, x1 minus 2, x2 plus 6 is equals to x2, x1 minus 3, x2 minus 2, x1 plus 6. Okay, so let us cancel the common terms. x1, x2 plus 6 plus 6. Now here x2, x1, x1, x2. You can just club them together. So I am going to bring 2x1 here. If I bring 2x1 here, it will be 2x1 minus 3x1 will be equal. Now this will go here. It will become minus 3x2 plus 2x2. So when you subtract it, you will get minus x1 is equal to minus x2. I can cancel minus. So I will get x1 equal to x2, which is very true. Therefore, my function is 1, 1, because I started with f of x1 equal to x2 and I am able to find x1 equal to x2. Alright, now let us go turn back. Turn back means going back on 2. So let y belongs to, what is our set? Y belongs to B, right? Y belongs to B. So y belongs to B such that y is equal to f of x. Okay. So what is our y children? What is our f of x children? Now here guessing is not possible, as even though I told that you have to go for example or counter example. Looking at the complexity of the set, complexity of the set is very difficult for me, because if I make some oral calculations mistake, then it will be wrong. So I'll go for general. Okay, so y equal to f of x. Now f of x is defined as x minus 2 upon x minus 3. This is given to me in the definition. Now just cross multiply this children. X minus 3, again x is not taking the value 3. Okay, because x is coming from my set A. Okay, which is not taking the value 3. Cross multiply. So xy minus 3y will be equal to x minus 2. Okay, now what I am going to do is I am going to bring all the x together, y different side. Okay, so what is going to happen children? I can do one way. I'll bring here xy here and 2 here. So it is going to be 2 minus 3y is equal to x minus xy. 2 goes here, 2 goes here, xy goes here. Anyway you do, you are going to get the same. So 2 minus 3y is going to be, if I take x common, I am going to get it as y 1 minus y. So my x is going to be 2 minus 3y upon 1 minus y. Okay, now you can see that 1 is coming in the denominator. Now you can be sure why b is given to be r minus 1, right? Because somewhere in the calculation 1 will be coming in the denominator. So in order to define, in order to make it well defined, they have given that exclusion. Okay, so now what will happen? Now this is definitely, now y is never taking the value 1, right? It is given in the question, y from b, y is coming from b, it will never take the value 1. So what happens children? This will never become 0. So what will happen? This will be always from your set, this will be always coming from your set A. Because A has only problem when denominator becomes 3. Now here even if denominator becomes 3, it is not having any problem because it is not 0. Okay, you have only problem when denominator is 0, but here denominator is not 0, right? Not become 0, right? Because it's coming from a. Now one more thing you have to check is, I have told you not only you have to find a pre-image, you have to prove this condition also, y equal to f of x. Okay, so I'm going to put this pre-image and I'm going to check whether y is equal to f of x. Okay, so let me do it side by side here. So you have f of x equal to f of x. What have you got x as? 2 minus 3y upon 1 minus y. Now how is your function f defined as? F is defined as, say, x minus 2, this number minus 2 upon this number minus 3. So how it will be looking like, children? This will be looking like this number. This is one whole number. This number minus 2 upon this whole number minus 3. Okay, now usual calculations. You can make a common denominator. So this will be 1 minus y, 2 minus 3y. You cross multiply, it will be minus 2, 1 minus y upon 2 minus 3y. You take here again 1 minus y. You are taking LCM here. Okay, I am doing here LCM. 1 minus y. Okay, coming back here. So I am going to get here 2 minus 3y minus 2 plus 2y divided by 1 minus y whole upon 2 minus 2 minus 3y minus 3 plus 3y upon 1 minus y. So this 1 minus y will get cancelled. 2 and minus 2 will get cancelled the numerator. So the numerator remains minus y. Denominator minus 3y plus 3y get cancelled. 2 minus 3 is minus 1. So I am going to get f of x equal to y. So that means, what does that mean, children? It means that for y belongs to R star, not R star, for y belongs to B, there exists x belongs to A. Okay, there exists x belongs to A such that f of x is equal to y. So what will happen? I am able to prove the question. What is my question? I have to prove, I have to prove that whether it is 1, 1 and onto. So I am proved that my function f is 1, 1 and onto. Okay, very simple calculation required here. This is at B. Okay. So I hope, children, I have done well with solving problems on different types of functions, and I hope by the end of the video you have understood how to check whether a function is 1, 1 or onto. Thank you, children.